Oh, you fool, you clicked on the wrong link.
Bah. Hello and welcome to the Hackaday Podcast. I'm Elliot Williams.
And I'm Jenny List.
This is episode 350, Damnation for Spreadsheets, Praise for Haiku, and Admiration for all the hacks in between. In Hackaday news this week, NASA may have lost their Maven Mars orbiter. It's always a bummer when your satellite stops talking to you. Maven has been up there for 10 years now, 12 years now. It was meant to probe Mars's atmosphere, but because, of course, there are so many robots walking around on Mars, it's taken over this kind of secondary function as being a relay station. And as one of the younger of the relay stations up there, it's kind of weird to have it go away. But it's not putting anything up there in a precarious position yet. The now really old in the tooth Mars Reconnaissance Orbiter, MRO, has been up there taking high-res pictures and also relaying messages back to the Earth. And there are a couple European satellites. I think there's a Chinese one, 4 or 5 different orbiting satellites that could serve that function now. So it's not a tremendously scary position, but it's always weird when one of your satellites just goes away.
I've heard Mars described in the past as a sort of probe graveyard because so many missions to Mars have failed in the final sort of getting into orbit or getting to Mars or whatever. Because, let's face it, getting any piece of hardware to another planet is hard. And we've been doing it now for nearly 60 years, and quite a lot of probes have been lost along the way. So, yes, they have lost the Maven orbiter, but then again, the Maven orbiter had been a successful mission for, 10, 12 years? That is a thumping success in spacecraft terms compared to the many Mars missions which have just failed. I'm immediately thinking of the British Beagle 2 lander, which disappeared off into the ether and was never seen again.
Yeah, and there was the one that with the now famous metric and imperial measurements mess up, which just crashed straight into the surface. Yeah, no, you're right. And Maven has done a ton of science, and it's actually one of the first ones that really gave us a good picture of what Mars's atmosphere looks like. Your point is totally right. It's done its main science mission. So, yeah, fair enough. No worries.
It's like Spirit and Opportunity. They had a mission that was in weeks or something like that.
Yeah, right.
And they went on for years. And I remember Opportunity was finally dragging around a broken wheel, but they kept on going for so long. We kind of get used to these missions when they're successful being very successful. But in fact, just by being that successful, they're way more than they were expected to be.
Yeah, they're all tremendously over-engineered.
Yeah.
And I think they're also very conservative with mission lengths. And, they really want to plan to get this science done, like 100% done. And then the rest of it is gravy over the top. And then, of course, like you say, they always end up, keeping on chugging for a decade afterwards. Fair enough.
Well, it's deeply impressive engineering to get there in the first place.
True indeed. Other news, more close to home, we will not be doing the podcast next week because of the holidays. So happy holidays, everyone. I think I'm going to try to put something cool together. It's not going to be a full episode, but, at least you'll have some little bit of podcast candy in your mailbox next week.
Sounds good.
This is a journey into sound.
What's that sound?
What's that sound?
And then that brings us to What's That Sound? This week is a reveal week. We played a brand new sound last week. Al failed to guess what it was. Let's see if Jenny can get it.
I think it's a rotary clothes dryer.
Oh, you are so right. And anything more specific than that?
It just sounds like a spin dryer. What happens when a spin dryer slows down?
Yeah, it may be a washing machine. I can't remember whether I went with a dryer or a washing machine, but you're in the right
it's on its dry cycle, and when it stops spinning, the centripetal force stops attaching the thing to the side, and it all flaps down and falls, and that's the bit you hear at the end.
That is good enough. I'd give you points for that one.
It's unfortunate that you tried it on somebody who was a farm kid in the 1970s and we had one of those dryers.
Right. Very good.
That's
very
the
good.
first time ever that I've got it completely right. I got very close last time, didn't I?
Everybody says this, but you guys actually do well. Our
Okay,
team
fair
actually
enough.
does very well.
I feel
I'm
that I
proud of
always
you
give
all.
entertaining but completely wrong options. Anyway, cool.
Absolutely appreciate that. We had a bunch of those. We had Tree Shaker, which is a great one.
Okay.
Snowblower showed up a number of times.
Okay.
Spinning down, stalling out. These are all the right ideas. Santa's sleigh engine running out of fuel.
I love it.
It's yeah, my absolute favorite because it's so very specific was a gold sluice slowing to a stop.
Yes, I suppose
I
gold
can almost
sluices
buy
do
it.
work in that kind of way, don't they?
Yeah, some kind of a rotary shuggy motor. I dig it.
The goldfields of Oxfordshire are very few and far between, so I'm not familiar with gold sluices, but I've read enough and seen enough like films about them and stuff to imagine they
Yep.
would make a noise, something like that. Yeah.
But actually, I think snowblower was probably as popular an answer as the
Okay.
correct one, which is washing machine, end of the spin down. Did anyone say that it was a washing machine? Here we go. An unbalanced closed washing machine, perhaps front loading Miele or Bosch since you live in Germany. It wasn't mine. I got it off the internet, SpyBob42. But that is officially the most correct answer.
Okay, I want SpyBob42 to have given us the model number and serial number,
Exactly.
but that's well done. Well done.
Very good, very good. Anyway, 15 correct answers. I'm going to the National Institute of Standards and Technology, which puts out a random number every minute, and
Cool.
it's actually kind of a early blockchain-y sort of thing. Each one is cryptographically signed by the next. If you know what time it is now, you can verify that I pulled down the right random number here and that it was unknowable beforehand. And this is the result. Let's see what we got. 15's downloading. The random number is 2. That's not very random. Washing machine spinning down. Ken Bob, congratulations. We will
done.
get in touch with you and get you a Hackaday Podcast t-shirt. And I was about to say, tune in next week. We'll play you a new sound. But next week's the holiday break. So we will see you in the new year with a brand new sound. First sound of 2026. All right. I'm going to start off the hacks this week with Kavish Devar's Liberating AirPods with Bluetooth Spoofing. And this is a write-up of the LibraPods project, which aims to be an open source, basically Linux, Android compatible control software for AirPods. And if you don't have AirPods, which I don't, so a lot of this was new to me, you can set a lot of the internal controls using your iPhone, but not, for instance, if you've coupled them with an Android device. So things like, the noise reduction mode, in-ear detection, pause, unpause, detecting head gestures, volumes, they have a hearing aid mode. A whole bunch of these features you have not been able to control from your Android or Linux computer, but now you can. A lot of this is made possible by some work on reverse engineering the AAP control protocol done by Sophie Tiali, and it gets a shout out in the project, along with a bunch of other people who helped debug some of the Android side things that were necessary to make these drivers work. There's still kind of one big asterisk here, which is that due to a bug in the Android Bluetooth stack, it doesn't quite work natively with your Android device. You need to get root and run it with systems permissions. This is actually not a problem with this software. It's a problem with Android's permissions system. Apparently there are some older versions of Android OS that it doesn't work with, et cetera, et cetera. So it's, there are a few dragons around the edges, but other than that, it looks like it's finally a system to control your AirPods from your non-iPhone, which is pretty damn cool.
Yeah, it's particularly cool in that I believe it allowed you to unlock some of the special features. For instance, I believe they have some kind of proper hearing aid mode, which you can only get to if you're an Apple user. And to be able to unlock those with an Android phone is potentially very powerful because there are a lot of people who need hearing aids and can't necessarily afford them. And that could be very powerful.
I believe you could get cheaper Android phones than you can get cheaper Apple phones. So
Very much
for
so.
people who need it, it's actually probably a very good thing. You can rename your AirPods. So if your AirPods are named, AirPods 1, 2, 3, 4, 5, you can change their name to Lefty and Righty, for instance, which is what I would name mine. Oh, the other funny caveat here is that some of the things require you to change the vendor ID of your phone. So it has to misrepresent itself as an Apple phone using the Bluetooth vendor ID to fool the AirPods into playing along. Is this sketchy behavior on Apple's part to try to make it only work with iPhones? Perhaps it is. Will this end up with trouble in the future? I don't know. Remains to be seen. Anyway, good news is that hackers are one step ahead in the compatibility race right now, and I'm happy to see it.
Okay, my first hack of note comes from Abe, and it's a camera. It's one that completely tickled my fancy for sort of funny homemade cameras. And it's a bit different from quite a lot of other cameras in that it's an analog video recorder. Now, obviously, it has a digital side to it. What he's done is he has taken the standard definition video kits that you can buy to go on drones, so a tiny camera and a tiny little solid state recorder, and he's made a handheld camera, very much in the style of a simple sort of point and shoot camera, which gives a lovely sort of 1990s video aesthetic to the recordings. It's not high quality by any means, but that's not the point with something like this. The point is it's fun and cool. It's walking a path that has been walked before by others, but many others will buy off the shelf a video recorder that has the battery and all the on-screen display and everything like that built into it. He's done this from first principles. He has actually found the chip, an on-screen display chip, and made his own little printed circuit board for it with his own little microcontroller board running it. And he's made his own recorder from first principles, which is quite something. But the way that he's combined it together in a really professional looking and really neat, cool looking little handheld camera is what sets it apart. These video recorders using drone gear can be done surprisingly easily and surprisingly cheaply. And I'd suggest anybody who's curious, just go out and do it. It'll only cost you a few tenors. But this one's a particularly nice one. I rather liked it.
Did we link in the video camera installed in a walnut shell that we ran this week?
Perhaps we should.
We'll have to go find that and do it. That's another one where someone took an old school analog quadcopter camera and wedged it into a walnut shell. Small battery, small step-up power supply, plus a drone video camera, and you are set. These things are really fun. I'm totally with you. The old school kind of analog over-the-air quality of them is either romantic or annoying, depending on whether you're flying a quad and discovering that you can't see the branches ahead of you until you're right on them because there just isn't enough resolution or not.
In the multi-rotor world, these are not old school. They use analog video for a very good reason, that it's got the lowest latency. Virtually every digital system has significant latency. And for them, they really need to see up to the nanosecond what is happening in front, rather than, let's just think, up to the 64 microseconds is a line period. So probably in the milliseconds what is happening in front of them, rather than waiting for all the digital gubbins to have encoded and decoded it. So that's why these things are available. It's the last sort of holdout of composite video. So if you're a composite video fan, that's where you have to look for your toys nowadays.
Yeah, for sure. I actually fly these very little quadcopters, and I have 3 of them on my desk right now. I'm looking at you, little Beta FPV Air 75. Yeah, no, and what's amazing is how small and light those transmitters have become. Like the transmitter plus optics plus electronics, not the battery, but everything else you need to get 5.8 gigahertz video broadcast weighs about 3 grams now. And, and fits in a walnut, if that's the sort of thing you're into. But it's true. It is really amazing. They get really hot. You have to.
Yeah.
I'm concerned about how long the walnut's going to last before it gets cooked. But a little extra room in that camera case, and he should be just fine. I like it. I like that idea of using it as a camera. That's really fun.
Well, I've done something similar with a old 1980s Nuvicon camera. It's a great big thing about the size of an old 8mm camera with a great umbilical cord. And instead of the huge, great big VHS carry bag that you would originally had, I have a power supply and one of the little solid state recorders. And there are some very neat little screens you can buy from Ali. They're just under a tenner. And this is something you just couldn't have even thought of doing back when composite video was a thing, because everything would have been so expensive.
Yeah, very cool. Well, changing scale entirely, we got some new news from the Sudbury Neutrino Observatory Plus. To talk about the sciences going on here, we're going to have to think a little bit about neutrino detectors. These are actually kind of one of my favorite science experiments because, on one sense, they're just dramatically simple. The idea is you have some kind of vessel and you put something in it that flashes when a neutrino goes through, and then you look for the light coming out of that. So it's a bunch of photomultiplier tubes, which are super sensitive to light flashes, and then some kind of fluorescing material on the inside. Neutrinos are the particle famous for being kind of least reactive with anything. You know, there's millions of them passing through you right now and you don't even notice. So the trick to making these experiments work is what makes them not simple, which is that they have to scale up to be ridiculously big and ridiculously sensitive and ridiculously shielded from everything else around them. And SNO is really fun because it's a big sphere of a scintillating liquid surrounded by something like 9,300 photomultiplier tubes.
Gosh.
The fluid on the inside weighs 780 tons, and to shield it from other stuff going on, from muons from a nuclear reactor that's 100 kilometers away and stuff, they have the whole thing surrounded in a shell of 7,000 tons of ultra pure water. And so basically the only thing that makes it into this internal sphere are things that don't interact with water, and so that's basically neutrinos. So they have a bunch of carbon-13 in the liquid scintillator, and when it gets hit by a neutrino and one actually finally interacts, it can turn it into nitrogen-13, which then decays in about 10 minutes. And so what's really interesting about this experiment is they have two flashes of light. They have one when the neutrino comes in and hits the carbon, and then they have a second flash of light a predictable amount of time later when the nitrogen-13 decays. And the nitrogen-13 needs about 10 minutes. I think it was 9 point something minutes to decay. And so what they're looking for in this experiment is a flash and then a flash 10 minutes later, and they have to be in about the same place. The other thing that's super cool about this neutrino detector is it has enough temporal resolution. It's sampling fast enough that it can tell you to within kind of a 10 centimeter cube where inside this volume it happened just by looking at the arrival times to all the photomultiplier tubes.
Yes.
So
Yeah, that figures.
it flashes and then the light goes out, and then you can kind of figure out where it must have been. So this explains why these events took place between 2022 and 2023. They ran it for a year. They got a bunch of detections, and they got something like 5-ish detections. But if you read the paper, they don't 100% know how many they got. They have 5.6 detections, plus or minus some confidence interval. And it took them 2.5 years to crunch the data to the point that they could classify these one way or the other. So it's kind of weird science because on one hand, it's really simple. It's neutrino comes through, makes flash, flash gets seen by photomultiplier tubes. On the other hand, the scale and the intensity of it and the volumes of data it's producing, and the fact that there's a whole bunch of other stuff going on, but they're only looking for this particular time lag signature located in a specific place, makes this actually really, really difficult, you know, when you actually start to unpack it. So really, really cool write-up. You should go read the paper, the PDF paper. You can pull it down from archive. It's actually really interesting detail into the way this thing works.
The trouble is, I'm not a particle physicist. People keep mistaking me for a particle physicist because no, they do, because my namesake Jenny List works at CERN and is a particle physicist.
Oh, right.
And so every now and then I get mistaken for her, and people say, "Oh, yes, you wrote that article in Scientific American," and no, actually, that was Jenny List.
Anyone who's seen my college transcripts does not confuse me for a particle physicist.
Well, yes.
But I loved it nonetheless. Anyway, if this piques your interest in neutrino detectors, we have 2 articles you should go read. One from back in 2023, Detecting Neutrinos, the Slippery Ghost Particles That Don't Want to Interact, which talks about this style detector and a few of the others. Very interesting write-up by Lewin. And then 2025, just recently, they had a neutrino detector in Japan, the Super Kamiokande, which had one of the photomultiplier tubes break, and then it made this horrible shockwave cascade. So they're vacuum tubes, basically, right? And so when it breaks, it implodes. And in a non-compressible fluid, that makes a shockwave that went out, and it broke a few more of the photomultiplier tubes. And then that broke a few more, and you get this like... And it was one of the bigger neutrino experiments at the time, and it all went pop like you dropped the glass light bulb on the ground.
The sheer amount of money involved there.
Yeah, you cannot even imagine. Yeah. Anyway, wrote that up just about a year ago now. Engineering lessons from the Super Kamiokande neutrino observatory failure.
Now, I have a very cool hack from Kevin Noki, who has built a Commodore 64 laptop. The fact that it's a Commodore 64 laptop is very cool in itself, because retro computer laptops are interesting. I just kind of want to sit on the train and type a Hackaday piece on an 8-bit computer one day. But this laptop is special because not only is it Commodore 64 laptop, it's the attention to detail in the design of the case. It's described as something along the lines of the laptop that Commodore would have made if they had made a proper laptop rather than the Commodore luggable they made with a CRT. And it is beautiful. It could have come from Commodore's industrial designers. It looks very like any other of the crop of mid to late 80s laptops. Laptops hadn't quite settled on the sort of clamshell design that we're used to for laptops. That really came in the 90s. And in the 80s, a laptop would have been, the front half of it would have been the keyboard and the screen would have folded up from the keyboard. And behind there would have been a sort of a heel, which usually contained the batteries. And this is very much in that line, but it's just perfect. It's not the electronics. The electronics are cool, but it's not the electronics that really got me going with this one. It's the aesthetic design and the attention to detail. Commodore could have made this thing. And there's part of me is looking at it and thinking, oh, it'd be cool to have a modern laptop in that case. I think the closest we've had recently, somebody did a recreation of the Grid Sextant laptop from, I believe, the late 80s, early 90s, with Raspberry Pi, with a similar level of detail. And this is on that scale as well. It's an absolutely beautiful device. If I never own one, I will at least be able to say I saw it on Hackaday and it was good.
I'll throw the link in for that one. I know exactly the one you mean. Well, let me see if I can find it. It's the Grid Compass.
Grid Compass, that was it. The Grid
what
Compass.
It is. Yeah, exactly. It's a totally similar aesthetic. Yeah, you're right here. I mean, a bunch of people are complaining in the comments that, it's an emulator on the inside and, it's not the original hardware, but that's not the point here, right? The point is to make it look. The other thing is that some people pointed out that Commodore made a portable, if not a laptop,
yes, they did.
The SX64, and I'd actually never seen that before. So if you haven't seen the SX64, you should go look that up. It's very interesting. Probably give you a hernia if you have to carry it around.
And of course, there's the ill-fated Commodore LCD, of which our colleague Bill Hurd has one of very, very, very few prototypes to have survived. Which wasn't. It was Commodore Basic sort of compatible, but it wasn't an actual Commodore 64 or anything. But it would have been. At the time, it would have, had it come out, like so many Commodore products that died on the operating table, it would have been the laptop to own. It would have sent that TRS-80 laptop that everybody used in the 80s for writing text. It would have sent that into oblivion because everybody would have wanted a Commodore LCD This is a different laptop from that, but the story of Commodore portables is full of missed opportunities like everything Commodore.
Oh, I like the Commodore LCD. I've never seen that one before either. Oh, how cool.
Why do you not? I was
Ah,
going to say, you should read Bill's book. It's really good, and there's a review on Hackaday.
well, there you go. Well, bringing up the rear for me, Playduino has a marvelous video about different approaches to level shifting. We've all had this problem. You have something that uses 5 volts and something that uses 3.3 volts, or it's 3.3 and it's 1.8 these days. Microcontroller and peripherals, they speak different voltage levels to get their data across. How do you do it? And there are a couple different cases here. It depends on whether you need to go unidirectionally, and if so, from high to low or from low to high, or whether you need to do a bidirectional level translation. That's what this video covers. It is superb. On the one-way high to low side, of course, the obvious thing is a voltage divider, but he spends a lot of time looking at that and thinking about what resistors you'd pick for the voltage divider, because that tells you how much current's flowing through it. And that matters if you have a little bit of parasitic capacitance in the circuit and you need it to switch really quickly. Of course, if everything's slow and you're not worried about your power budget, just throw a couple 1K resistors in there, a 1K and a 2K resistor, and call it a day. But if you're trying to save power, they need to be higher values, so there's less current flowing, and then you have to worry about the capacitance. The worst way to go from high to low is to just put a resistor in the middle and hope that the protection diodes on the lower voltage device handle it. And he actually suggests this as a possible solution. The risk is if you play too close to the edge, it'll burn the protection diodes in whatever the lower voltage device is. So don't do that, kids. A better solution, he points out, is to use logic chips that are run on 3.3 volts but are 5 volt tolerant. And so you just buy some kind of CMOS IC that can handle the input. And he suggests the AHC and LVC series of logic chips. The C stands for CMOS. Going the other way, low to high, you could have it run a transistor, MOSFET, or a BJT, doesn't matter to me. That inverts the signal, so you can either invert the signal in your code on the other end so that it works out right, or throw a second transistor in there. That starts to get complicated. The way I like to do it is similar to the CMOS way, going the other way, except this time you use a TTL logic level capable chip, so an HCT kind of logic circuit. And this one you give it 5 volts, but the threshold between a 1 and a 0 is set up so that it works with the 3.3 volts. Do not make the mistake of using the CMOS ones where you need a 3.3 volt circuit, because even the highest, the 3.3 volts, is kind of in the gray zone between the logic switching levels there, and you will end up suffering. Ask me how I know. And last, he does the traditional trick of abusing a MOSFET to do bidirectional communication with voltage shifting. And this is kind of the Philips I2C trick. I guess it's enshrined in their app note 97055, which I went looking for on the internet, and Philips may have pulled it. It was just kind of too hacky for them, I think.
I have noticed a lot of older Philips amp notes have gone missing. The one for I2S has also gone missing. You can find it, but it's not where it should be. And when NXP happened, a lot of the old Philips ones went missing.
That's a shame, because this one is an absolute classic. It's an off-use, some would say a hack, using the MOSFET to do this bidirectional level transition. It uses, the body diode in one direction and pull up, pull down in the other. It's a clever circuit, and it's beautifully written up, and and everyone's implemented it since then. So it's well worth knowing that trick. And I think that's the end of the video. You should absolutely go check out a piece on Hackaday 2016, taking it to another level, making 3.5 and 5 volt logic communicate with level shifters, written by Jenny List. It's even better. Jenny covers all these bases and a couple more.
Impressive.
But also a great video from Playduino, if level shifting circuits aren't your bread and butter.
I will have to go back and read that now and remember what I said.
I actually was reading it again. I updated the link to the
Oh, okay.
Philips app note for everybody. So if you're looking for it, you'll find it in Jenny's piece as well.
That is useful. My final hack of note comes from Ivan, and it's a MIDI slapophone. Now, if you don't know what a slapophone is, it's one of the musical instruments that's made out of a group of PVC waste pipes cut to different lengths. And it's called a slapophone because you slap at the end of the pipe and it makes a sort of dull thwink kind of noise at a note. If you get enough of them together and you've got somebody skilled with a set of bats, they can play. It makes quite a cool musical instrument. And what Ivan has done is he's made a MIDI one, and instead of taking a full octave or several octaves of notes and having a whole load of actuators and slappers, he has instead got only 3 tubes, but each tube is variable length. It's got a servo and a sort of chain arrangement that's a bit like a sliding joint, like a trombone, and it can make any of a range of notes. And all this is MIDI controlled. And he has slappers which are a bit like a motorized table tennis bat on the end. And it makes a great noise. As I understand it, it's sort of half and half MIDI and manual, in that something like the MIDI changes the note, but the operator has to play the note or something. I didn't fully understand from when I read it, when I scheduled it, but it's a very, very cool musical instrument because of the sort of trombone style slapping. I wonder if you could do some kind of pitch bend kind of thing as well. The trouble is, it's by its very nature not a sustained sound. So it's not like, say, I don't know, a guitar with feedback where it'll keep going as long as you want it to. It's just the individual impulse from the slap, and that's it. But if you could move it while it was doing that, you could get some kind of pitch bend on it. It's not often you see a completely new take on a musical instrument because, let's face it, Hackadays, the people who we write up, are very inventive. And this was one I had never seen anything quite like this before, and I thought it was rather cool.
Well, my first quick hack, Wi-Fi menorah for 8 nights of bandwidth, is ridiculous. This is a sweet 3D print by Brian that on the end of a not quite kosher menorah has 8 Wi-Fi antennas, inspired by the kind of Wi-Fi pineapple multiple antenna array. I don't know if this is art or science, but it looks like fun either way. Wesley Treat laser cutter plus CMYK spray paint equals full color prints. He ends up cutting stencils out of Mylar with a laser cutter that do kind of halftones, but 4 color halftones. He starts on this path because he found 4 different color spray paints that are meant for doing exactly this with, and thought, if you have photo editing software and a laser cutter, you can make the 4 different color overlays yourself, register them just right, and the effect looks really cool.
And the cat is very cute.
And last up, this one's even more absurd than either of the previous. Why push a button when a machine can do it for you? We've all had this problem. There's a button over there you need to press. You can't modify whatever the device is. So you want to make a 3D printed frame, attach a servo motor to it, and have that motor press the button for you. Somehow he does this by pressing a button in this room, and there's some kind of magical radio waves, or maybe it's 2 ESP32s and the ESP Now protocol talking in between the two of them. This is just a frivolous, funny hack from What's Up TK here, who is actually our own writer, Lewin Day, in disguise.
Starting my quick hacks is a bit of a surprise for me because I thought Linux already had it, but Linux has, for the first time ever, got stable GPIB support. And what that means is GPIB support in the kernel, as I understand it. I've used GPIB with Linux in the past, but I've done it using National Instruments Visa, which is an abstraction layer. So it's possible that's what I thought was the thing that was actually missing. GPIB goes back to the early 1970s, so it's about time, really. Second up was a very impressive piece of metal casting. It was a good introduction to metal casting and particularly making your own green sand, which is always the bit that's missing. When I read through that as I scheduled it, I thought I actually learned something here and I want to try it. That's one of the things I want to actually do in the future. That's what part of being a Hackaday writer, that you keep seeing things that, wow, that's cool, I want to do it. And because you're spending all your time writing and editing Hackaday, you never quite have the time, but never mind. And finally, a real cautionary tale, something which I never considered. I've grown up in and around a blacksmith's business and a welding shop. Somebody unfortunately cleaned something with brake cleaner and then welded it. Then died of phosgene gas exposure because brake cleaner is a chlorinated solvent, and the hot mess of welding made a great reacting place for it to break down and I think react with the air and make phosgene, which he then breathed in and then sadly caused his death. It's just natural if you work in a metalworking shop to just use an angle grinder to clean up your work. You'd never waste solvent on it. But if you didn't know, and oddly I didn't actually know this one, if you didn't know, you might just spray some solvent on it to clean it and then weld it. So that's a cautionary tale for all of us and quite a sad story.
Well, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week I picked Al Williams's A Brief History of the Spreadsheet. The reason he was looking into this was the 40th birthday of Excel. But don't be fooled, this article is not about Excel at all. It's actually about the history of spreadsheets before Excel. If you haven't seen this on the page, you absolutely should check it out. This is, I think, my favorite Joe Kim art of the week. It's got like the caveman carrying a rock and a 1700s guy taking notes on paper and then a computer person with a spreadsheet. Absolutely fantastic art. Spreadsheets are wild. They are older than I thought they were. Of course, it depends on what you define as what, but Al points to LANPAR, language for programming arrays at random, as being the first kind of spreadsheet. It had cells, you could label them, and it did the multiplication-y stuff. Back in the day, apparently, people hired programmers to make these kind of reports at the time in Fortran, but it took a lot of time to do so, and if you changed anything in there, it was hard to retool it. It took a sophisticated programmer to do the retooling. And I think that's kind of the appeal of the spreadsheet, is that it's easy enough to manipulate things without obviously writing code. That's also what I personally absolutely hate about spreadsheets. Like, each of these cells is a spot that can contain a number or a piece of code. And we have names for these. It's called a variable. And the nice thing about variables is you get to name the variable. So it's not called, sheet 7 cell A4, right? Like, it has a name that means something if you pick smart variable names. And then when you write out the function for it, you can actually see the function as well instead of it being hidden opaquely in a cell in some spreadsheet. And so you're never sure which of the cells are data and which of the cells are functions operating on data and what they're referring to. And you go try to debug these functions and it's like, oh, it's B1. And then you have to go back to B1 and figure out what the hell's there. If you could just use variables and write this in code, the world would be better. I think spreadsheets are a step in the wrong direction. I honestly haven't used a spreadsheet since the 2000s because it's easier to do the same work in Python or in any programming language of your choice. I don't understand people who use spreadsheets. But Al loves spreadsheets. And we've seen a bunch of hacks where people do absolutely insane things with spreadsheets. So congratulations. There was a 3D spreadsheet where the sheets were stacked on top of each other, invented by Boeing Calc. There are spreadsheets running on old hardware, spreadsheets running on new hardware. He runs the gamut here. It's a fun article to read. It still doesn't answer my question of why you want spreadsheets. But that's left as an exercise to the reader. Send your hate mail to the comments at Hackaday.
Well, if you read that, you'll know when the first spreadsheet happened, but you probably won't know when the first person realized that they should have used a database for the amount of stuff they were storing in their spreadsheet.
Oh, right. That's the other thing, right? Like I hate that the functions are hidden from you, but it also makes it impossible to store astronomical amounts of data because each one has to have a cell on the screen and you have to be able to see them. And if you need to scroll through them all, God save you if you have a million table entries.
I've met more than one programmer who makes a nice living out of going into companies that have a creaking enormous spreadsheet that runs their entire operation that they're dead scared is going to break someday and turning it into a database application which is more reliable.
Yeah, exactly. Little bit of code in a database and you're done. On the other hand, there is something very human about thinking of the places. I'm putting this number in this place. That is it really is like, putting your data in a cubby hole in a mail sorting thing or something. It really is this physical location space. And I think that makes it easy for a lot of people to think about.
I feel it's in the interests of responsible disclosure that I reveal that Elliot and I are both staring at the schedule for this podcast, which happens to be in a Google Sheets spreadsheet.
Oh man, here goes my second spreadsheet rant of the night. The other misuse of spreadsheets, which are meant to do math, and we use them for this like kind of trivial low-level formatting. Like what in this spreadsheet that's in front of me is actually anything that a spreadsheet's supposed to do? Nothing. It's absolutely horrible, and it chokes on the links, and it makes them hard to manipulate. Oh, dude, spreadsheets.
I'll put some maths in there now so you can feel happy.
Just write a formula that says, equals Lewin plus cell D72 or something. For the love. Oh, I'm triggered, people. I'm triggered.
Sorry, I've ruined our credibility there, haven't I?
I've always thought that something people need is a better alternative to a spreadsheet for doing this kind of grid structured text layout. Like, so you don't need any of the mathematical and the cell reference and the multiple tabs and the sheets and all that stuff. But what you do need is I want to put text here and I want to have it nicely formatted this way and that way and maybe syntactically formatted. If there were a language that you could use to write things on the internet and have them appear on the screen in specific places like HTML or something. But then you have to ask people to learn CSS text box style and stuff, and that'll drive them crazy too. So that's where the spreadsheet is still sticking around in this like alternative use where, people write their schedules on a spreadsheet because it makes it easy to put text in boxes. That's not what a spreadsheet does. Like if you look at the toolbar, it's all these things about numbers and formatting and is this a time? Is this a decimal place? Is this a dollar sign? But then there's all the other stuff up there that's like, what color should I make this cell? Which doesn't matter if you're doing math, but of course is the whole point if you're just doing layout. So weird. Spreadsheets are so schizophrenic. Damn it, my spreadsheet rant. Anyway, articles about history. Go read it. It's a good one.
Yes, it's a good one. Well, on that note, my can't miss article this week is actually, it's a terrible piece of self-promotion. It's one that I wrote, but it's actually something that I was very enthused about, and I'm still enthused about it, and I want to enthuse about it at you. It's one of my long-running Jenny's Daily Drivers series, where I take an operating system and try to use it as a daily driver, by which I mean I try to use it to write a Hackaday article, because that's my daily sort of work, the thing I do every day. If I just did, yet another Linux distro, it would be very boring, so I usually try to find something a bit unusual or esoteric. I have done some Linuxes, but it's usually there's been a good reason for doing that particular Linux. But this one was the turn of Haiku. Haiku is an open source continuation of BIOS. Now, if you don't know what BIOS is, it's an operating system from the mid to late 90s. In that period, when it still seemed as though there could be reasonable competition in the operating system and hardware market. You had the ashes of platforms such as the Atari, the Amiga, or the Archimedes just about staggering on, and you had Apple just about to find a new life under Steve Jobs with what became Mac OS X. And into that came B. B were a startup. They had this really cool multimedia operating system, and they had a computer called the B Box, which the fans who had them at the time still rave about them. They were apparently very good. They also produced the B operating system as a standalone operating system. You can buy it for your PC. And if you went to a computer or multimedia exhibition in the late 90s, as I did, because I worked in the CD-ROM business, you would see B-Ink stand. And I actually had a play with BIOS at the time. You'd wander onto the stand, they have a whole load of machines with BIOS, and you'd have a play and go, oh, wow, that's really, really nice. And then, of course, you'd never actually use it because you were working in the time CD-ROMs for the Windows operating system. Obviously, B didn't make it. I think they were swallowed by Palm in the end, and they sort of just disappeared. And out of the ashes, a bunch of enthusiasts have built Haiku, which has had 25 years or so of development, and I'm very, very pleased to say is an amazingly useful operating system. It's not a Linux. It's not building on another operating system like most Linux distros, or even things like Reactos are taking things from Wine. It's entirely own standalone operating system they've built from the ground up. And I was very pleased to say that it was a genuine daily driver. It felt very 1990s in its interface. It felt like stepping back to a 1990s desktop. There's no bad thing about that. It was a very, very slick and very well implemented 1990s desktop. It was stable. It worked beautifully, with the one exception that it didn't like my Wi-Fi card. It would connect, but it wouldn't connect reliably. And I could do my work. Has a software repository. I could download GIMP and forget for a moment the name of their browser, but their browser is a modern and up-to-date browser using the WebKit engine, so it's quite happy with Hackaday and Hackaday's back end where I do my work. And I could have this on my laptop and just use it. I could take it on the train. I could go anywhere. A few things it doesn't do. For instance, when I tried to plug in another screen, it didn't recognize the other screen, but I'll forgive it that, because the sheer amount of work that goes into making an operating system like this, the fact that they've made one so slick and stable and useful as they have, is an amazing achievement. So this is probably the first really esoteric Jenny's Daily Drivers that has been a genuine daily driver. I'm not counting the couple of Linux distros I've used because they were interesting distros. I kind of expect a polished Linux distro, like for instance KDE's reference distro, whose name escaped me for a second. I tested that because it's an immutable distro and I wanted to test an immutable distro. I expect that to work because it's Linux, it's got a modern desktop, it's got the perfect reference implementation of KDE, and it has obviously up-to-date browsers running as Flatpaks, and I can get GIMP and anything else I want. That I expected to work. So that, of course, was a daily driver. Something where everything is done from scratch from within a small team. It can be a little less polished. Some of the other operating systems I've tried have worked, but have been a bit slow or unwieldy. But Haiku is genuinely lovely.
That's fantastic. Reading this article, I'll admit it made me want to check it out, because I have no idea what an operating system that isn't Windows or Mac or Linux would even be. I mean, looking at your screenshots here, there's nothing that's particularly strange looking. And
No.
I think some of that is because the early, iconography of what a GUI looks like hasn't changed that much, right?
No, I guess not. And also, B obviously did have an influence on some of the operating systems we use now. I found everything intuitive. Everything was in the right place. There was one minor hiccup. I installed it on a hard drive that had previously had a Linux distro. So I had some problems with the boot up, and I had to sort of install the files to make it boot. And so I had to dive into the command line. And I'm obviously a Linux user. It's Linux-like in its syntax, in its command line, and I found nothing that I didn't understand. It worked well. There are a few slight problems in that it's very much a multimedia operating system, so they've concentrated on what you might call mass market applications in their app store. I can't fault them on that. The amount of work involved, they've done an incredible job. But if you're wanting to do slightly esoteric or particularly engineering things like your favorite CAD package or your 3D printing slicer, you may find that it's not in the repository. But given the amount of work involved to maintain a vast repository like a typical Linux distro has, I'm not going to fault the Haiku team for that. What they've done is amazing. If you fancy trying Haiku, I would say go ahead and do it. It won't disappoint. It didn't disappoint me.
Well, that does it for this week's Hackaday Podcast. Thanks very much for listening. As always, you'll find the notes over on Hackaday at hackaday.com/podcast. And if you see anything cool that you want us to write up, shoot us an email, tips@hackaday.com. And until next week,
Eat, sleep, hack, repeat.
I think that's it. Do you have anything else to say on these?
Right, are we done with that one, I think?
Now I'm done.
And the fact that it's a Commodore 60 laptop. Okay, let me start this again.
Da 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 da. Should get their names, but it's not in the article. That kind of sucks.
Still recording? Yeah, that's all working. Good.
No, that's not going to work. Fine.